shower as long as you want, or just fill the jacuzzi, like a millionaire with no bills attached. In this video, I want to show you how, by using magical power of science, of Ohm law, we can make it work with any, even junk solar panels, any panels you can put your hands on. I am a cheapskate, so to avoid plumbing and any costs, I propose you to use your existing water heater. So at the beginning, I've got a big ask for you. Go to your water heater and check the nameplate. Check the wattage of the heater first. It is written as a number of kilowatts or watts on a nameplate of your water heater. If you have it, now I've got a surprise for you. The number you just read and maybe even wrote down is straight up lie. In reality, power is not the parameter which your heater has. This number you read from the nameplate is voltage of your AC, so it could be 120 or 230, that depends which country you are in, times current which flew through your heater, because your heating element is resistor. So let's say most popular is a 1.5 kilowatt heater element in small heaters. We will use small heater because it's easiest for everyone. 1.5 kilowatts, most viewers of this channel are from US, but the calculation is the same for everyone. Let's say you've got 120 watts. To calculate current, you need to divide wattage by voltage. What does it mean? Why does it matter? Because now I can reveal you why we did these calculations at all. Because now we can calculate resistance. And resistance is this magical controller for our solar panel. Resistance of our heater, any resistor for that matter, is equals voltage divided by current. Now we've got voltage and current, we can calculate resistance. Our heater is 9.6 ohms, and how it will control solar panel. Let's go to the marketplace. Let's find some cheap or free solar panels. I couldn't find free, at least usable free, but I found solar panels which were advertised as $3 per piece, but in fact they are $5 per piece. Usually people put photo of nameplate of solar panel. We need from this two numbers. One is VMPP, which means voltage at maximum power production. Here it is 69.4 volts, and IMPP, which means current at maximum power production. And using these two numbers, we can calculate how much power we will generate and how much these solar panels we need to connect to our existing heater at home. Because it is exact number. Solar panels are a little bit like donkey. If we load them too much, they will get stubborn and do no work. If you load solar panel too much, the voltage drops to zero, current even rises. Short circuit current is higher than current for maximum power production, but everything multiplied by zero is zero anyway. So our donkey will stay and not carry our load. So let's calculate this load for this panel. First and most important, voltage on solar panels stays the same in almost or changes very little in every conditions. Solar panels are the source of energy where voltage is semi-constant, but the current changes a lot. And for us, it's more important that our system will work every day, or at least 300 days a year, than that it works perfectly in very sunny days. So we need to calculate it for lower voltage, for less sunny days. I assumed, because as engineers, you usually do it like this, that you assume value which is good enough for your use. I assumed 0.8 amps. What does it mean? That there is ideal resistance where this solar panel will give maximum energy out. If we would have such a small resistor connected to this solar panel, it will be perfect. So let's calculate what kind of resistor is this to receive 70 watts from this 80 watt solar panel. It's the same like previous. We divide voltage by current. If we would have such a resistor, we will receive 70 watts from this 80 watt solar panel without any controller, without any MPPT. So what to do when we've got 9.6 ohms resistor? Let's check how many solar panels we need to connect to this resistor which we already have. Which means if we would have heater with resistance of 86.5, we will receive 70 watts of heat from this 80 watt solar panel. But we have at home heater which got 9.6 ohms resistance. What can we do? Let's calculate how many our small donkeys, our solar panels, it will take to carry the load of this heater. 903, which means that if we buy from this guy 9 solar panels, $5 each, $45, we connect them in parallel because voltage stays the same, we need higher current, we will receive source with 69.4 volts because voltage is the same, but with 72 amps, which means we will have 9.6 ohm, which means that our 9.6 ohm heater will work perfectly with it and our donkeys will carry the load. Of course, it's not real magic, it's not perpetuum mobile. Our heater will not have 1.5 kilowatt from 970 watts panels. It will have about 600 watts, but it will work constantly because if you check your heater, often it is disconnected. It's connected, disconnected, connected, disconnected. And this is the real biggest issue of this system, because if you want to heat swimming pool, you just put the heater element inside and forget about it. But with home water heater, there is one big problem, which is thermal disconnector, because water boils. When it boils, pressure rises, everything breaks. So that's why we're using thermal disconnector. And these thermal connectors, they are designed to work with AC current. AC current is easier to disconnect because it doesn't produce electric arc, which is very common with DC. And it's quite a big problem because after a few disconnections, our thermal disconnector can burn and stop disconnecting at all. But solution is very simple. It's capacitor. The same type AC capacitor you are using to start electric motors. When you connect this parallel with thermal disconnector, it swallows up the arc, so it can work forever. Okay, if you are a wealthy individual, you can go and spend another $5 on DC disconnector, but if you save that money, in next video we will tell how to add $150 to this and make free electricity for home.